All right, 3a. The key thing here is that the function g is the derivative of function f. So I would think about that as f prime equals g, but I can also think about that as f being the antiderivative of g. And if we remember our second fundamental theorem, if I am looking at values or integrating values of g, the integral from on any interval of the g function is going to be the change in its antiderivative. So that's going to be f of b minus f of a. So that's our fundamental theorem of calculus. It's kind of in disguise, but it's really important here for 3a. In this case, my values are -5 and 1. So I'm going to use -5 for a and 1 for b. And if I look at that integral, I'm going to get the change in f over those two values. This ends up being something I can figure out from the graph. This is 3, and this is what's being asked for. So we can do everything we need to do. The integral from -5 to +1 is made up of just geometric areas, so I can figure that out. So I'm going to start off with this rectangle here, which is -9. And then I have a small sliver triangle that's 1 by 3, so that's going to be -3/2. And then I have this, which is a positive triangle, that's going to be +1/2. Adding those up, it's -18/2 minus 3/2 plus 1/2. And so that's -21 plus... oh, I'm sorry, that triangle is 1 by 2, so it's 2 over 2, and that's 1. So it's actually -18 minus 3 is -21 plus 2/2, so that's -19/2. That's going to equal 3 minus f of -5. So that means f of -5 is going to be 3 minus -19/2, or plus 19/2. That's going to be 6/2 plus 19/2, which is 25/2. Again, the trick to that one is actually a little bit tricky as the fundamental theorem there. All right, letter B, it asks us to do a straight integral. This problem's a little bit easier. When I look up here from 1 to 6, I notice that part of that integral is going to be geometric shapes. I have a square right there. But the other part is going to be defined by a parabola, and so I'm going to have to work that out. But in letter B, I need to break that apart. So I'd be looking at the integral from 1 to 3 and figuring that out with geometry, and then figuring out the integral from 3 to 6 of this quadratic, which is 2 times x minus 4 squared. All right, again, this one with geometry is just this square right here, so that's going to be 4. And then here I have an antiderivative, x minus 4 to the third over 3, and I still have my coefficient of 2, and I need to evaluate that at 6 and at 3. So I get 4 plus, when I plug in 6 here, I'm going to get 2 cubed, which is 8, so that's going to be 16/3. And when I plug in 3, I'm going to get -1, so that's -2/3. And with a common denominator, I'm going to have 12/3 plus 16/3 minus 2/3, that's going to be 26/3. Let's see. Oh, you know what? Sorry, this should be minus a -2/3. Minus a -2/3. I missed that. So that's actually a plus, and this is actually 30/3, which is 10. Sorry about that. All right, for C, are there any open intervals where the graph of f is both increasing and concave up? So again, it's important to remember that f prime is the graph that we're looking at. Also, f double prime is going to be the slope of the graph that we're looking at, okay? If f is increasing, f prime is positive, and if f is concave up, f double prime is positive. So I'm really looking at when these two things are true. When is g have a positive slope? I'm sorry, when is g positive, and when does g have a positive slope? So positive with a positive slope is going to happen from 0 to 1. and also 4 to 6. So those are your two intervals, and the reason why is this, right? It's the places where G is both positive and G prime is positive. It's important to kind of state this relationship in your answer, but something along those lines would be a good solution. D, x-coordinate of points of inflection. So we're looking for a change in sign of f double prime of x, right? Remember that f double prime is going to be the same as g prime. And so we're looking at when do I see a change in sign of g prime. So here I have a g prime that's 0, positive, 0, positive, 0, negative, positive. The only place where I'm actually seeing a change in sign is x equals 4. So that's my only point of inflection. Now some people might argue that I'm going from positive to negative, but because you have this flat section, it's not going immediately from positive to negative. So there's no such thing as like a line of inflection. It has to be a single point where you're going from positive to negative or negative to positive. So 4 is your only answer for D.